from Jérôme Raynal. So Jérôme is director of Aeronautics and Composite um, in Institut de Soudou group. So he is quite experienced in liquid processing of composite, but now is focused on the welding of thermoplastic in an industrial way. And the presentation is an innovative solution for welding for structural applications in aeronautics. So please, Jérôme.
Hello, good afternoon, everyone. Hello to everybody. I don't know if you can see properly my screen.
So we can see you.
Okay, this is not the most important point.
Okay.
Now, it's okay?
It's okay, so go to presentation mode.
Perfect.
Okay.
Okay, so thank you very much, Pedro, for the introduction. Thank you very much, Jack, for giving me the opportunity to make the presentation today. And so my topic will be about welding of thermoplastic. And this is a new solution that we have developed that I will introduce today. So going through a quick introduction, I will present you Institut de Soudou Group, and then we will jump in the technical presentation, going through presentation of the technology, a little bit about modeling, performance, ongoing development, because this is still under development technology, and I will share with you our development plan for the next months. So quick introduction first about Institut de Soudou Group. So we are a French company, we are a French group. We are specialized for more than 100 years in welding of metallic. And we are doing a lot of activity around metallic and welding activities. So meaning expertise, inspection, a lot of NDT and training. And since, as we say, for the last 15 years, we have initiated a development in, of course, composite development in the group, with a strong focus now on the welding of thermoplastic. And this is the topic of today. So first, let me introduce quickly ISW Technology, meaning standing for Innovative Solution for Welding. So this is a technology that we have developed and patent jointly with the company Arkema, with a French chemical company specialized in high performance polymers. So the specificity of our technology is that we are using indirect induction heating in order to weld two substrates made of thermoplastic composites. And as you can see on the video at the center of the screen, I would say the specificity is that the heating is located at the interface. So we are using a mobile coil that is linked to a mobile susceptor that is located between the two elements that we want to weld. And we will concentrate the energy, meaning the heat, at the interface. So we are not fully heating the components, and we are not decompacting also. So we localize the energy that allow us to have different kind of characteristic, and that allow us to weld with LSP and so on, something that I will share with you just after. So this is a fully dynamic and automated technologies. We have been awarded in 2020 with the JEC Innovation Award in JEC Paris, and with our partners that follow us from the beginning with the development. Arkema, of course, this is a partner of the development, but also Excel, Stelia, and Latecoère. Around this technology, and because the main target of this technology is to be able to weld, I would say, large part with a strong target for aeronautics, and meaning fuselage components, we have to set up a lot of monitoring and process control around the technology. And this is the first item of my presentation. So we have developed a solution that is fully monitored. So meaning that if you have a look on the slide, so you have an image that you can see. I don't know if you should be able to see my arrow. So you have
Yeah.
the mobile susceptor that is located between the two substrates, the metallic susceptor, and we will be facing from the top using a thermal camera, I would say the setup. And we can see on the video, you can see the coil and you can see all the holes that you can see here that will allow us to access the temperature at the interface. So with our technology and with the setup that we actually patented, this is a perforated sample, we can access both surface temperature and interface temperature. So we can monitor and adjust the parameter in order to induce and to generate a good melting at the interface. If we have a look on the plotting of the temperature, so we can see that, of course, when we are facing a hole, we have access to the interface temperature that is higher than the melting point of the thermoplastic. And when we are facing, I would say, a solid surface, not in front of holes, we have access to the surface temperature, meaning that we are way below the melting temperature and we are not affecting the full component, meaning we are not decompacting and generate defect in the substrate. So this is one of the main characteristics of the technology. After the item on modeling and on monitoring, we have a strong focus on the modeling because as Pedro just mentioned, we have a strong expertise in LCM and all the simulation. It is around RTM and infusion, and we have the same strategy for the welding. So we want to be able to fully anticipate and optimize the process through modelization. So we are working quite hard on setting up a model that will allow us to fully simulate and anticipate the welding. So this is some illustration of where we are now. So we have set up a 2D model and we are working on a 3D model that will be a multi-physics model in order to integrate, of course, the induction modeling, but also all the conduction that we have between the susceptor and the composite, and also through the thickness of the composite. As illustrated here, we have the full simulation of the heating wave through the thickness, and this is a threshold that is only focusing on the melted area. So this is a strong focus that we have now on the modeling. Speaking about performance, we have a target that we developed with Stelia Composite. It is Airbus Group in France. And our target for the process is quite simple. We must be higher than 85% in terms of mechanical performance of the welding interface compared to the reference that is done through autoclave consolidation. So we must be higher than 85, 90%. If we have a look first on the right side of the slide, so this is an example of mechanical performance that we can get on a study that we are running right now with Stelia, but this is illustrating what we get usually. So if we compare the mechanical performance of the welding joint with the reference, in this case, we are about 100%. So meaning that we are on target. We have the same performance between, I would say, the raw material that is consolidated in the autoclave and the performance of the welding line. So we have quite a good status right now. So, and this is what we are targeting for the next. Also, what we are targeting is to be able to weld any kind of material. So this is the case. We can weld any kind of matrix, starting from PA, polyamide, up to high performance material like PEC, PIC, and PI, LMPAK, and so on, and also different thicknesses. So this is what is illustrated in the table on the left side. So between 7 plies up to 40 plies. So we have no problem, I would say, to handle welding on quite thin and up to thick components. So this is the message of this slide. We have a wide range of capability with our process. In terms of dimension, also the only dimension is, I would say, the capability of the robot to move the welding head along the welding line. So up to several meters. It's okay because we are not using a strong and heavy jigs or heavy tool. We are just using light jigs just to handle the component in place. And I would say the welding head will do all the job by heating, cooling, and compacting in the same time. Just about a little bit of performance, I would say, of capability of the process. So these are some micrographs that show you, I would say, that we have a good interface. Welding line is quite homogeneous with the substrate, and we have no degradation, visual generation of defect at the interface. And also what is very important is that with our technology, even if it's induction-based technology, but it's indirect induction, we are able to use and to weld component with LSP, lining strike protection. So this is what we use to perform, and we know this is a requirement of aeronautics to be able to have this lining protection, and we can handle this with our technology. About chemistry, because this is also important to demonstrate, at least to highlight the fact that we are not degrading the polymer at the interface. I would say very close to the mobile receptor that is generating all the heat in order to induce the melting of the thermoplastic. So if we have a look on this GPC, molecular mass repetition. So this is an illustration on PMMA, because we can also weld PMMA, meaning the helium resin from Arkema. But for any kind of polymer, we have done this, and we are not degrading the polymer at the interface. This is also important. Of course, we are working on the crystallinity level after welding. So this is under progress, but at the end, we are not degrading. This needs to be optimized in terms of crystallinity, but we are not degrading the polymer. Also important point. In terms of development, because I told you that we have already done some development, some project. We have demonstrated some capability in terms of welding, in terms of shape, thickness, and so on. I will show you and share with you after that. But we are moving step by step, and we are still in the improving in terms of geometrical components that can be handled with our technology. So we started with flat components, small coupons, up to flat, up to flat skin with omega Z L shaped stringers. Then after that, we moved to in shape skin and in shape stiffeners. And this is, I would say, where we are now. And I will share with you a little bit of what we have done already. So this is the illustration of what we have showcased in JEC for the JEC Award in Paris in 2020. So it was, I would say, some flat skin with some I-beam, stiffeners. Then now we are able also to handle some flat skin with omega stringers, with multi high beam stringers. Still with high performance polymers. So what we are showing now is at the screen is made with PEC resin and carbon fiber products for Stelia Aerospace. Now you have an illustration right now where we are in terms of in shape, because as I told you, our main objective is to be able to weld some stringers on fuselage application. So meaning omega and high beam on in shape skins. So we have set up a demonstrator quite large. This is the small that is illustrated on the video. Quite large sample of tooling with a 4-meter diameter that allow to weld in shape. So this is and of course the illustration, but of course again we are still on target with mechanical performance. In this case was 95% of the reference.
So Jérôme, 2 minutes left.
Yeah, no problem. So this is for the welding on the other side, so axial and transversal welding line. Multi-stiffen panel. that we can handle with our technology. So showing the versatility of the technology and of the equipment. And now sharing with you, it will be my last slide on the roadmap, the development plan. So we are now at the way that we can handle, let's say, in shape, curved skin with omega high Z stringers. I would say 1 meter by 1 meter, 1.2 meter large sample and demonstrator. And we will move forward quite large demonstrator end of next year, I would say, with multi-Stephen panel in shape that will demonstrate the capability to weld the fuselage component. We are also working hard in the same time to improve the welding speed. We are around at 0.5 meter by minute today, improving the modeling and also the monitoring. And we are also focusing a lot of energy on the NDT, meaning the quality inspection of the welding. So this is where we are now. Roughly, this is what I wanted to share with you. Even if the number of slides is shown as 33, I have only 25 slides, so I am on time. Thank you very much for your attention. I am still available, and I will be always available for any question if you have on this hot topic of welding of thermoplastic. So thank you very much.
Okay, so thank you, Jérôme. Now it's time for some questions. So there is any question from the audience?
Is there any question or comment from the audience? 질문이 있으시거나 코멘트가 있으신 분은 손을 들어주시면 저희가 마이크를 전달드리겠습니다. Seems like there's no question or comment. Thank you very much, Mr. Raynal, for your presentation, and also Mr. Venus for being a chairman for the session. Thank you very much for both of you. Thank you.
Thank you.
Okay, so thank you. So I have just a small question for Jérôme. So if it is possible from the time. So Jérôme, your system needs this compaction unit after the heating. So this is so okay for welding stringers or frames in a panel that we can have a backing structure, but I am thinking a little bit more in assembly line of thermoplastic section. So to weld different sections of a fuselage in an assembly line. So it is possible to make this welding with a limited amount of pressure, because if we have to install a backing structure in the assembly line to support this compaction pressure, so probably it will be quite massive tooling.
Thank you very much. I understand your point. In fact, perhaps I have been too not enough clear on my explanation, but the welding head itself is making the heating, the cooling, and the compaction. So we do not need any external device to apply the pressure. With the welding head, we have some rollers that are applying the compaction. And so I would say the welding head is quite compact and is all in one. So we do not need bagging and so on to apply the pressure. Everything is included and embedded in the welding head. This is your question? So meaning that we can weld large component, but also quite small, reduced to 500 millimeter long with our welding head, and only the welding head. The only thing we need is some jigs just to maintain in place the components.
Okay, so
thank you.
Thank you very much. And so with this presentation, we close the session. So thank you very much to all the attendants and all the presenters. And so we keep in contact. Okay, thank you.
No, thank you. Bye.
Thank you very much.
Bye.
I'm afraid to inform you that all sessions and sequences of JEC Korea 2021 Technical Conference have been finished for now. And we appreciate to all of our speakers and participants from all around the world. And we hope you scaled up your knowledge of composite via JEC Korea 2021. And I'm looking forward to meet you at next JEC Korea. Once again, thank you very much for your attendance. Thank you.